Is that all, Shekhar? Should we get started?
Yeah, I think so. You can start.
All right, perfect.
Yeah, thanks.
All right, so good evening, everyone. Um, I'm Tivish from Capgemini's Connectivity and Network Engineering Group. I develop embedded-based solutions specifically on the routers product by working with top-tier operators in North America. And it's a pleasure to be here to talk about one of the most, exciting evolutions happening at the intersection of connectivity, intelligence, and sustainability, which is so-called the smart home ecosystem. So over the next few minutes, we'll explore how technologies like Purple operating system, Matter, and generative AI are reshaping the connected home landscape, enabling seamless interoperability, predictive insights, and sustainable innovation. So, uh, so we just get started with the smart home landscape and trends, how the current market is evolving with the latest technologies, and we'll just deep dive to Matter Standard, how it addresses the interoperability challenge, generative AI in smart home ecosystems, agentic AI, Wi-Fi sensing, and some video analytics use cases, sustainability, data security, and last we have for Q&A session. So, and we hope everybody will have some questions. So let's allocate the final hours to be a perfect Q&A session. Let's make it interactive. All right. So as per current market migration and transformation map, uh, we have wireless devices, wired devices, and those are connected to the residential gateway, which typically every home has a router product for our internet purpose, right? So we're all surrounded by smart devices, bulbs, cameras, plugs, sensors. But the true intelligence lies not just in each device, but in how they work together. And that's exactly where open platforms like Purple operating system, like Matter, come into play, creating a unified, secure, and interoperable foundation. So these are some emerging trends that is evolving in the current market. For example, Purple operating system, Matter, which is an emerging IoT protocol, edge analytics, with which every operators in the current world are interested in taking upon this solution and deploying to their router products. Generative AI, agentic AI, WAN failover, which is a business handoff, which is basically a switchover between one network to other network, Wi-Fi 7, Wi-Fi sensing, and so on and so forth. So the smart home market has evolved from device level automation to ecosystem intelligence. We now see trends like multi-protocol integration, Wi-Fi, Thread, Zigbee, and AI-driven personalizations. All right. So Purple operating system. This is pretty new in the current market where every operators are trying to make use of this operating system to be deployed into their residential gateways for many advantages and benefits. As I said before, when the number of connected devices grows, so do the challenges: interoperability, data privacy, and energy optimization. So um, let's talk about Purple operating system a bit. So as I said before, today every connected home, from smart thermostats to IoT gateways, relies on a secure and interoperable platforms. That's exactly what Purple OS delivers, which is an open source based, modular, and a career grade operating system built for the next generation of connected devices. So Purple operating system intelligence in a way that it has segregated into three categories: your low level APIs, middleware, and your high level APIs. So low level APIs are basically manufacturer constraint, OEM constraint. So it differs between gateways to gateways. For example, a manufacturer A would have their specific Wi-Fi drivers, So the LL APIs would be defined in such a way that it talks to those low levels. And the middleware component, which is widely the same, and that's where this benefits across multiple operators. And this HL APIs is what we use as a technology where we could deploy many user space applications, which enables smart applications too. So this enables high velocity service driven innovation for customer premises equipment, which is basically our residential gateway, by offering a standardized open source platform with abstraction. So as I said before, in the today's world, many operators started using Purple operating system. For example, AT&T, Verizon, and the other telecom operators started using this. So if I deep dive into Purple software architecture, this is how it looks like. The low level API, which I said, it's basically manufacturer constraint. Hardware, it's hardware based. For example, if an hardware is based on Broadcom or Qualcomm, the Wi-Fi drivers differs. And this middleware components is what the Purple operating system benefits. So this is pretty much the same across all the gateways. For example, if you take a DHCP component, this is something like you have it in your mobile phones, you talk to internet, which is IP based, right? So this component is nothing but, this component is nothing but a functionality where it provides IP to all your end devices. And if you take an example of VPN, it's basically you connect your devices remotely through tunnels, for example, IPsec, and so on and so forth. And if you talk about QoS, quality of metrics, it's basically you monitor all your connected devices quality of service metrics. For example, if you want to monitor your devices delay, you can monitor, or jitter, packet loss, throughput. And if you talk about DNS is something which gives you an abstraction layer to talk to your external world, the so-called internet. And the HL API, which is high-level API, is what we concentrate to deploy all our smart services. For example, Matter, which I said about, that addresses interoperability challenge. The Edge Analytics, which is AI-based concept, GenAI, and Agentic AI. All right. Let's talk about Matter a bit. So as per the current problem statement, what every users are facing is, let's say a user buys a bulb A, which is from TP-Link, and buys a plug, which is another manufacturer called Tapo, right? So in order to control each and every devices, you need to have their applications. For example, you need to have a TP-Link app to control your TP-Link device. You need to have a Tapo app to control your Tapo device, and etc. Right? So that's how Matter comes into picture, which addresses interoperability challenges. So irrespective of the radios, for example, if a Matter-based devices are Wi-Fi, or if it is a thread-based or a Zigbee-based, no matter what, your Matter will address those challenges, having a unified application to control irrespective of your OEMs are. So right now in the current market, there are about 25 plus different OEMs that are currently in place. So if you go to Amazon and check out, if you want to buy a smart bulb, there are a lot of listings as well. So Matter addresses this fragmentation, right? So it provides a common application layer for device-to-device communication, regardless of brand or protocol. So it combines with open platforms like Purple, allowing us to deploy that as a smart service, which is basically in a containerized form, where it allows gateways to natively onboard and manage Matter devices, which is lights, sensor, logs, which is securely and uniformly. So this is how the matter works. So we have a residential gateway, which is basically an edge gateway, which is a Purple operating system based, which I talked about before. So this is loaded Purple OS, which has Matter as one of the services running as a Docker container. So it controls all your Wi-Fi based devices, media devices, thread based devices, etc. So it's easier device provisioning, low latency, better data traffic optimization, um, security and privacy advantages, reduce burden on external network, and does not require a connection to the internet. So if you take an example of Alexa or Google Home, and when you want to onboard a Matter device, it typically needs an internet. So without internet, you can't really onboard a Matter device. But the software that we develop has a capability that it doesn't necessarily have to talk to internet. And that's the intelligence that we bring as far as Matter controller is concerned. All right. So with all these devices in place, your bulbs, your plugs, lights, so one has to give attention to how it works, or what kind of analytics that I can do inside my edge gateway, such as to make sure it behaves well, it operates well, it performs well, and user have an uninterrupted internet service. So we have also developed a machine learning artificial intelligence based software where it keeps detecting for any abnormal patterns. With that being said, there is a machine learning model in place which is very less footprint for about 10 MB size that is made to monitor your smart devices traffic. For example, if a device is performing um, in a rogue based, or it creates an unwanted packets which pumps your residential gateway, thus leading to interrupted service, your edge analytics engine will come into picture, starts monitoring those traffic, and will pre-alarm your operator, such as to make sure any precautions can be taken before. So as I said before, Purple operating system allows users to deploy smart services with which Edge Analytics engine, which is running as one of the Docker containers in the residential gateway, which monitors all your smart-based traffics. So the Edge Analytics engine has a lot of capabilities. For example, it does device-based analytics, network-based analytics, hardware-based analytics, home appliances, and your cellular-based analytics. And in the today's world, one has to design a software adhering to standards. So when I say standards, there are different standards currently available in today's market. For example, if you take an operator's world, there is something called USP. So that's user service platform, where one has to design a software with data models exposed. So this Edge Analytics engine has data models designed in such a way that it has been managed securely and using your operator's cloud network. So which is basically this, where operators have an access to your deployed gateway so as to monitor and manage all your smart-based end devices. So this is how the Edge Analytics architecture looks like. And this is how it will look like when it has been deployed into each and every one of your residential gateways. Right. So next comes the GenAI platform. So you need to give a bit of intelligence to your residential gateway. So when I say this, it's nothing but an AI. So AI model can answer some of your user queries that is made to give us some benefits. For example, if In a typical home environment where there are uh, many devices connected, smart-based devices connected, and you would like to know how each and every devices are performing. As a developer or as an operator, they would have an access to remotely manage the gateway, and they can collect data whatever they want. But as an user, experience matters, right? So that's how Gen AI plays a vital role in each and every residential gateways. For example, this is assume this as a chatbot, right? So an user can query among all listed devices which one is performing poorly, what is its QoS status, provide a tabular view. So the edge analytics engine, which has an LLM integrated, will process the user queries, collects the low-level data, understands it, and responds with a response that this particular device, which is your it can be anything. This is for an example, right? So this Shelly Plus, it's a smart based device performing in a way that it is signal the signal strength is minus 68 dB, which is considerably a good signal strength, TX rate, RX rate, TX bytes, RX bytes, and it says that device is experiencing poor reception quality, which is likely impacting its overall performance, right? So this allows user to manage in an easier way that one could manage all their smart based end devices. So this LLM is based on OpenAI, with which our organization has a Capgemini generative engine platform where one can use or leverage any LLMs that they want to use, depends on their use case. So for this use case, we have leveraged OpenAI's GPT model, and it's been currently deployed as one of the Docker containers. All right, so with that, I'll hand over to Ajay to proceed further.
Sure, Chris. Let me turn on my camera. Share my screen. Okay, awesome. So, great. I'm Ajay, and so far Divish explained you how generative AI works and how we can use it to understand better about our networks and how devices work in general. And Gen AI has been the talk of the town for a while, and almost all the companies that use Gen AI are now adding agentic AI into it. But there are like so many definitions of what agentic AI is, and think of agentic AI as a natural evolution of generative AI. If generative AI is one LLM model that can think by itself, agentic AI is a group of LLM models that has somehow figured a way to communicate with each other. And they've also understood that now they can communicate, they can bring shared experiences, and can also accomplish a single task by working and collaborating together. I think that's how agentic AI would stem from Gen AI. This slide might look too much, a lot of information, but let's break it down. Compared to generative AI, think of agentic AI as your very own ChatGPT. But instead of just, let's say you're talking to ChatGPT and you're hosting a party and you're asking ChatGPT, hey, I'm hosting a party tonight. How should I decorate my room? ChatGPT is going to come up with a set of plans, and it's going to be very generic. You can do this, you can do that, but that's it. That's all it can do. Now, with agentic AI, it has a better understanding of your home. In this case, it has an understanding of what are the lights you have, what are the devices you have, where it is, all of that. Now, if you ask the same question to an agentic AI framework, I have a party, what should I do? It's first gonna understand what you're trying to do, and it will use its knowledge of your smart home, and it will say, oh, okay, he wants to prep the home for a party, and he has lights here, here, and here. So I'm gonna go and turn on this. And how it will do that, since it's running on the edge on the platform you see here, it can communicate directly to all the devices using all the protocols that Pirish just mentioned, Matter, Wi-Fi, Thread, all of that. And it will also come up with a logical reasoning as to why it did what it did. For example, let's say this is your entire home, and, your agentic AI framework looks like you have an orchestrator agent, or let's say a manager agent, and you have another agent that controls all the devices, and there is another agent that just takes note of everything that's been done so far. Now you're saying, based on the current weather, make my living room comfortable. So the manager agent will first receive the input, and it will decide, okay, this is something the control agent can do, and it will assign it to the control agent. The control agent will understand your query and come up with a list of steps that you should take to accomplish the goal. Once it's done with that, it's going to use something very cool called tools. Tools, think of it like a bridge between your LLM and the real world. Tools can help LLM accomplish tasks in your world. So let's say it has to turn on a color light. The control agent is going to decide, oh, okay, I have so many tools, and I have access to a tool called control tool, which can control all these devices. So I'm going to use this tool to, let's say, activate strip lights, activate color lights. I'm going to turn off bright white lights. I'm going to unlock the doors. It will decide what it should do. It would use the tools that are available to the agent, and it will get it done. Another cool part is if the control agent is met with something that it can't solve. Let's say I'm asking something about today's weather. Control agent has no idea. It can only control the devices. What it will do is it will search for other tools or agent that has the same capability, and it will pass the task to the fellow agent and ask its help to get it done. Just like how if I'm stuck, I would ask the wish. Exactly like that. The agent would assign the task to a friend or to another agent, and based on that result, now it can take an action. If the agent says, oh, it's sunny outside, we should reduce the temperature. Okay, based on that information, the control agent will go and reduce it. And these are some of the cool prompts that we can try. And let's get into how exactly is Gen AI different from agentic AI, apart from what we discussed. Like I said, it's more like Gen AI is for generating really good content that anyone can understand. It will break down the text and give it in a way that any human can understand. Whereas agentic AI would actually interpret what you're trying to say, and it can interact or control a certain set of actions defined by the user, of course, and it'll get it done. Also, it's not like a one-off thing. If let's say if you're asking it to turn on a light and set it to red color, and when the agentic AI is trying, it understands that, oh, this doesn't have a color setting. It will come back to you and say, this doesn't have a color setting. What should I do? And you could say something and it'll go back and do it. So there's a back and forth communication between the user and the agent and amongst the agent. If something fails, it will still come back and try to do it again rather than just failing. And hallucination is something both Gen AI and agentic AI are prone to. If you're used, I bet all of you have used ChatGPT. And if you're asking it a couple of questions, at some point, it will be very, very confident that something is the right answer. when it's completely wrong. That's hallucination. And the same can happen with agentic AI. For example, if you're trying to turn on a specific light, it will be very confident the light is on and it's set to red at maximum brightness, but it wouldn't have done anything. That's hallucination. There is no way to deal with hallucination in generative AI. But since agentic AI can interact with the real world, if it fails the first time and if it assumes it has turned it on, another agent could check if the light is actually turned on. If not, it could complete the loop by saying like, oh, you actually didn't do it. That can't eliminate hallucination, but it can reduce the probability of hallucinating. But it's like all of this sounds cool, pretty fascinating, I'd say. But is it actually something you can deploy it in field right now? I wouldn't say so, because this is very embryonic. From OpenAI to Google, everyone is like working on it, but it's a very cool stuff, and it would be great to see how this goes. If you want me to paint a picture of how agentic AI would help your smart home, if you watched Iron Man, I'm a huge Iron Man fan. If you watched Iron Man, remember Jarvis and how the Tony Stark character uses Jarvis? It knows your entire home and it will talk to you in natural language in real time, and it will also manipulate stuff in reality. It's a stretch, but if we can get agentic AI to fix all the hallucinations and have a better control of your home, I think that's where we are going. Okay. So if you're done with generative AI, agentic AI, and there is no smart home without a smart camera. And that makes sense to me, because if you have camera, there's a lot of information you could get out of it. But overall, computer vision, you can do a certain set of things, and this is just a few of the things that you can do. Of course, it's not exhaustive. We can start with object detection. That's the most standard use case. You can detect objects, or you can segment them, get a map of it, or you can estimate depth, know how far an object is using cameras. And you have pose estimation, which, like, as you can see, gets the joints or the skeleton of a body. And then you have tracking, which kind of not just detects an object, but tracks an object through each frame. And lastly, we have character recognition. It's been there forever. The usual is number plate detection. If we can use all this with custom dataset, more and more training, we can deploy it in a way that suits our different use cases. Let's look at some of the use cases that we can use in a smart home setting or in a restaurant setting. Let's say we start with fall detection. The pose estimation algorithm gives you a good idea of how a human body is like. Is it standing or what it's doing? Based on all these points, we can guess or we can extrapolate if the human body is in upright position, is he or she standing or on the floor. And that's fall detection. And we can use intruder detection, which is like face recognition. It's like embedded in almost every camera right now. You can detect a face, train for a person, and recognize it. And there is violence detection, which is something cool. We'll get back to that in a minute. And number plate detection is the same character recognition with object detection, where you detect the number plate first and then recognize the characters. Okay, now let's get to violence detection. So after LLM, after the whole transformer-based architectures, people tried using the idea of transformers to computer vision. So how can a transformer model understand an image? Is it as good as it understands text? Turns out it is. The way VLM works is, if you are giving it an image, it's going to convert it into an encoding. And that encoding is going to be so good that you can use it for a lot of use cases without actually having to train it. It's called contextual understanding. Like, it understands the scene as a whole instead of just looking at a specific object. Like in this case, we are only trying to look at the number plate. Unlike that, this understands the scene in its entirety. That's how a VLM or a transformer architecture would differ from our traditional object detection. And let's say if we have a model that's good enough to understand an image, and we have another model that's good enough to understand the text, the user input. And we have a third model that can fuse both these information and give out a single output. Now we are sending an input information, let's say it's an image of tomatoes. And we have the text input to that is, how many tomatoes do I have? If our fusing model is good enough, it would understand the embeddings from the text and the embeddings from the image, put it together and say, okay, I see there are so many tomatoes on the table. That's close to ChatGPT. You can do that in ChatGPT, but if you're splitting it like in this way and using a separate embedder, encoder, and a single model to fuse them, you can run it on the edge, which means all of this gets to stay in the edge. It doesn't have to leave your home. And privacy is the top concern for any smart home. So all the use cases that you see here will be processed in the edge, and it doesn't even have to leave to the cloud for processing. So this chip here, that's where all these computer vision algorithms will be running. You must be familiar with NVIDIA. We also use that. But this new chipset here is called Halo. It's like NVIDIA. If you want me to compare with NVIDIA, I'd say if NVIDIA is Ferrari, Halo is your Toyota Camry. Depending on the use case, you pick what you want. If I had to choose, I would pick Toyota Camry because I just want to go from point A to point B. I don't want to go super fast, just a decent speed. That's good enough for me. So I'll pay less and I'll get a Toyota Camry. That's exactly what Halo is when compared to NVIDIA. It's very cheap. If NVIDIA is like around $600 or $800, this is like $150. And it can run almost as good as NVIDIA, but it may not be best suited for models that are more complex, let's say a heavyweight vision language model, but it can very easily run simple object detection models or those feature extractor models that we saw for violence detection. So once we have the video stream that passes through the gateway and we have a Halo processor that runs all this, and that can be sent to cloud or directly to the app, wherever the user wants it to do. And since it's running on the edge, you can also trigger devices that are available locally. Let's say you detected a fall. Instead of sending it to cloud, you could just trigger a device, an alarm or whatever locally, so that if someone is not right there, but let's say I'm in the first floor and someone fell down in the ground floor, then I could just rush down because I saw an alarm. So this way we could have a whole computer vision architecture running locally in real time, and it's secure because we don't have to secure it because it's running locally. It doesn't even have to go to the cloud. We could integrate it to the cloud if you want to display what's happening, but all the inference workload will be running locally. So that's computer vision. Before we get to Wi-Fi sensing, let me show you something kind of cool. Yeah. So I was talking about agentic AI, and even not today, but until recently, agentic AI felt very abstract to me. It's like, okay, that is ChatGPT and that is agentic AI. How would I really use agentic AI? And this will answer that. So let's say I'm saying I have an important meeting in the living room, prep the living room for the meeting based on today's weather. That's something I would say to my roommate who would understand what I'm saying and the home we live in, and will go do stuff. Let's say I say the similar command to agentic AI. This is what happens under the hood. the task gets assigned to an agent. That agent comes with a set of rules and the prompt that the user gave. And it will say, okay, I understand what you're saying. And in order to do that, I should first check what's today's weather because you asked me to prep the living room based on today's weather. So it's going to Google today's weather in Texas, McKinney, Texas, and it's going to get the output from Google. And with that understanding, now it's going to say, okay, I see today's weather is around 54 degrees Fahrenheit, and I should create a comfortable space in the living room. To do that, this is what I'm going to do. I'm going to adjust the thermostat. I'm going to turn on the main lights in the hall, and I'm going to adjust the blinds. Now it has an action plan to solve the query. Now it has to find a tool that would help the agent accomplish this. And that tool is Trigger Smart Device. There's a list of tools like we saw in the architecture diagram, and this is the only device that can control all these lights and blinds. So it decides, okay, I'm going to use this tool to accomplish all of this. And it's going to say, okay, set the thermostat on and set it to 72 degrees, turn on hall main light, turn on the blinds, turning on, in this case, it will open the blinds. It will do all that. And once it's done, it's going to come back to me and say, okay, I've done so-and-so. And why did I do that? To allow optimal sunlight. That is, you can see how it's not just I asked something and it gives me something. It reasons it out, plans what it should do, organizes the plan, and goes and actually completes the plan. If any of this fails in between, let's say a device isn't working, it will come back to me and say, oh, I tried this. These are the things I tried, and it didn't work. And it'll go to the next step. Now it's for me to figure out why it didn't work. Okay, that's what I wanted to show about how agentic AI can actually help you. Before we move on to Wi-Fi sensing, let me ask you this. Whenever you use ChatGPT, it says, while it's loading, it says it's thinking. Now my question is, you can just a question or something for you to think about. Is ChatGPT really thinking, or is there something else going on? If you're convinced it's actually thinking and it's not taking a shortcut, it's actually truly understanding what you're saying and it's interpreting how a human would interpret. If you believe that, check out the strawberry R problem. It's a problem that all LLMs faced until the last month or so, or last 2 months or so, where it couldn't understand strawberry or in a let number of R's in strawberry. So if you're thinking ChatGPT really thinks it can understand what you're saying, just Google strawberry R problem. Let's say you'll be surprised. Okay, now let's get back to our Wi-Fi sensor. Okay, if you're someone who loves technological sci-fi movies, James Bond movies, all of this, you're gonna love this. Let's start from scratch. We all used ultrasonic sensors at some point, used ultrasonic sensor to measure distance, all those Doppler effect and all of that. Let's say in your home, you have 10 or let's say 20 ultrasonic sensors stuck on all sides of your wall and you're standing in the middle. The amount of information you can get from that is a lot because every time you move, the ultrasonic sound is going to hit on you, bounce back, and it doesn't necessarily have to bounce back to the same sensor. It could bounce back to the nearby sensor and it will eventually reach the actual sensor that emitted the sound. With that rich data, you could to some extent say if I'm standing, if I'm walking, or if I'm on the floor, if I fell down, based on what happened through a 5-second interval. Now, forget ultrasound, forget ultrasonic sensor. You have Wi-Fi routers in your home that emits signal. you have Wi-Fi devices in your home that sends a signal back. What if you can somehow move the same ultrasonic perception algorithm to Wi-Fi? And what if you can say where a person is, what the person is doing, or how the person is based on the Wi-Fi signals that bounces off this person? That, in a way, lets you look into a room without actually looking into a room. All rooms have Wi-Fi signals flowing in and out. And I can measure that. If I can measure that, I can guesstimate or estimate where a person is based on how the signal bounces off. If there is no one in the room, it's going to be quiet. There's not going to be a lot of deviations in the signal. But when someone enters, the signals are going to bounce off this person and I'll get a very different graph. That's exactly what Wi-Fi sensing is. There is something called CSI packets that are emitted when a device is communicating to another device. Let's say your Wi-Fi router is communicating to your phone, for example. If you have a router that can emit these CSI data, and if you have another software running that can capture these CSI data that are bounced off from different objects, you will get a very good source of data with which you can somehow understand what's happening in the room. And the somehow here is a machine learning model. This data, it's not going to be an ultrasonic sensor. It's a Wi-Fi data. So you're going to have tons and tons of values. So you have a machine learning model. In this case, we use something called LSTM, which is a long short-term memory. Remember I told you we could use this over a span of 5-second window to understand what's happening in that window. This LSTM is meant exactly for that. It understands what happened through a period of time. Now, if I send all these Wi-Fi CSI packets to this algorithm that can understand all of this through a window of 5 seconds and tell me, oh, in this 5 seconds, I think this is what happened. That's it. I have a view of what's happening in the room with 0 cameras without invading anyone's privacy, but I would say so. And I could use this to basically do anything I said I do with computer vision. I can do fall detection. I can do violence. Almost anything I would do with computer vision, I can do it without invading anyone's privacy. But of course, there are some drawbacks with it. It can reach about 45 meters. So what happens if it's a multi-story building? What happens in that case? Or if there are 2 apartments close to each other, will the Wi-Fi signal from the other apartment affect mine? It probably would. So there are some of the challenges, but overall, it's also a very, very important problem of using cameras, which causes a privacy concern. Using this will eliminate cameras for most of the use cases, and it comes inbuilt with your Wi-Fi gateway. You don't have to get an extra piece of hardware, none, just software, because your Wi-Fi router and phone are already doing most of the work. They are sending and receiving Wi-Fi signals back and forth. So just making use of it, you would get a number of use cases that we can solve by using Wi-Fi sensing. Okay, and back to Divish.
All right, thanks, Ajay. Let me just share my screen again. All right. Thanks, Ajay, for talking about various use cases, which is computer vision based, agentic AI based. And yes, so we spoke about a lot of current technologies, the current market evolving standards, technologies, right? So it's time to benchmark all these technologies in a real-time manner. So we created a smart home environment, which is Purple based. And so we have named it as Purple Home because it is Purple operating system based, where we have energy-based devices to monitor each of your electrical appliances. We have about 75 plus Matter-based devices, which works over Wi-Fi, Thread, Zigbee, um, and we have Matter controller software running as Docker container that is going to address the interoperability challenge, um, and Wi-Fi sensing, as Ajay discussed, Edge AI, which runs as another container, and some video analytics use cases. And we have designed a single pane of glass, which allows user to control your electrical appliances, your Matter-based devices, to monitor all your security use cases, such as intruder detection or fault detection, etc. All right. So with these technologies in place, there are other such emerging topics, other such emerging technologies, which is widely being popularly used in the current research. One of them is Wi-Fi 7. Um, so Wi-Fi 7 uh, is is the next generation of wireless networking, which is designed to deliver multi-gigabit speeds, ultra low latency, and reliable performance for data intensive and real-time application like AR, VR, 8K streaming, etc. So in the current residential gateways, we have 2.4 gigahertz, 5 gigahertz, with which 5 gigahertz operates at the 160 megahertz frequency, whereas Wi-Fi 7, which is twice the 5 gigahertz frequency, which is 320 megahertz, allowing the traffic to spread across multiple bands. Assume you have a 4-lane highway, um, and you travel during a peak hour, right? So when there are more traffic, uh, you of course lead into lesser time reaching your destination. But think of a highway where you have 8 or more lanes, such as the traffics are much lesser, and you can reach your destination as quick as possible. So similarly, Wi-Fi 7 has a lot of bands, frequency bands, with which your clients will travel along each channels. Thus, which doubles the bandwidth of Wi-Fi 6. And so right now there are many smart phones where it's Wi-Fi 7 based, which can talk to all the bands 2.4, 5, and 7 gigahertz. So this is the advantage of making use of Wi-Fi 7, which is being currently evolved in the current residential gateway markets. So this is one of the most interesting use cases that is currently in research, which is dynamic path selection, where when a residential gateway has multiple interfaces, let's say fiber and cellular, so how seamlessly it switches over from one fiber network to other network, thus by having any uninterrupted services. There is something called StrongSpan, which is an open source based, which allows to play around with tunnels, which is IPsec based, and all your routes are basically routed into multiple tunnels for fast service and uninterrupted service. In order to route your multiple traffics, there's something called BIRD, which is called as BGP, which is another open source, where it allows traffic to travel along multiple tunnels for any fast services. So let me talk about BGP a bit more. So where IPsec ensures secure tunnel, while BGP ensures intelligent routing across those tunnels. So there are benefits of using BGP. Um, some of those are dynamic route exchange, no manual static routes, automatic failover and recovery. It scales well across multiple sites or tunnels. It is compatible with both IPv4 and IPv6. So in a typical home environment, as we discussed, we have a lot of IT-based devices, your Matter-based devices, which is both Wi-Fi and Thread, your video camera-based cameras for video analytics use cases, your energy appliances, smart devices. So how do you make it more efficient in a way that each smart end device's traffic are traveled along different tunnels, such as to make sure it operates at an ideal performance without any interrupted services. So advantage, right, let's say, as I said before, when an extension gateway has two links, fiber and 5G, how seamlessly to switches over between one network to the other network. This is an example, right? So if a latency of one device which is greater than 100 millisecond or packet loss which is more than 1%, so this SD-WAN controller will dynamically reroute the application to travel along different tunnels. All right. So we spoke about a lot of technologies, standards, but one might has to give attention to sustainability, right? So from that perspective, LoRaWAN plays a vital role in monitoring your sustainability. For example, so LoRaWAN, it's a long-range based sensor where it enables low power, low-range communication for IoT devices in environmental monitoring. So this is again another open source chip stack, which is available as Docker, where we can leverage those Docker containers to be deployed into any residential gateways, such as to onboard any LoRaWAN devices to monitor some of your sustainability aspects. For example, if you want to monitor your soil temperature or soil humidity, one can use a LoRaWAN-based soil sensor, or a temperature just to monitor your home temperature, etc. So so this will enhance ways in a smart agriculture. One can use the soil humidity sensor to monitor their humidity, moisture level, etc. So let's say when they are in a remote place and they want to access how the soil is behaving, so one can use LoRaWAN and start using it. So these are some references. We'll share it across to have a quick look at it. All right, so I'll give it to the forum now for them to have any questions. Feel free to raise any questions. We'll be happy to answer.
Yeah, I think we have one question.
About 5%. Ajay.
With Wi-Fi sensing, how are security challenges being addressed in security breaches?
You're on mute, Ajay. You're on mute.
Oh, sorry. That's a great question. And here's a fun story. This whole Wi-Fi sensing concept is very, very new. It's not popular, but the idea has been there for a while. And guess what? All Wi-Fi routers emit CSI data. Let's say you have a Raspberry Pi. Before Raspberry Pi 4, if I'm right, there was a way to measure CSI data, which means CSI data is basically packets sent by Wi-Fi to your phone. So if I have a Raspberry Pi 3, and I have the necessary software to capture CSI data. And if I'm close enough to my neighboring apartment, I could technically sniff packets from them. And like you said, that is a security challenge. And that's kind of why after Raspberry Pi 4, they don't allow anyone to access the CSI data. But it's been a while now, and the only way to make it secure, like you said, is not open source it and maybe integrate it with your standard gateway so that there is a set of any data that comes out of this follows a set of procedure encryption, for example, so that even if I'm trying to sniff my neighbor's CSI packets, I really can't do anything with it. It's all encrypted. So yeah, it is a real problem, and I think that's why, although this concept has been there for a while, that's why Wi-Fi sensing is not in the market yet. It's an active. It's still a problem. But yeah, encryption would be the way to solve it. Thanks for the question.
Thank you. Anyone has any more questions?
Okay, another interesting question. Okay, since you asked this question, let me talk about the strawberry R problem. Or at least OpenAI has fixed it now, but I think Google's and Gemini model still has that glitch. So the strawberry problem is if you ask the LLM how many R's are there, the letter R are there in strawberry, it would either say one or it would say two. It would never say three. The reason for that is how the encoding model that understands text works. The LLM model understands text in numbers, like in bytes. So it's going to do something called tokenization, which splits the entire text into tokens and it will feed it to the model. So if the tokenization splits strawberry into two words, straw and berry, and if only one token is being used to answer the user's question, it's going to say either one or two. That's like an example of how, although this LLM is like so super generalized and intelligent, can simply fail with a very simple trick. To answer your question, why this happens? Okay, it's like they're not really thinking, honestly, or at least that's what I see it. They are trained on the internet, a huge data source which contains human interactions, human conversations. So when you ask a question, what's today's date? It's going to refer to all these data that it had. It has been trained on all these data, and it's going to try to answer your question using those data. If I had to simply put it, ChatGPT or any LLM model is a really, really, really good text completion model. It's just completing the text. It's not actually understanding it and answering it. That's the difference between if I ask the wish, like, what's today's date, versus if I ask ChatGPT, what's today's date. They're going to understand this prompt very differently because ChatGPT is trying to answer based on what it knew, based on the text. That's why we see a lot of glitches and jailbreaks of how we can get ChatGPT to answer something when it actually shouldn't. So yeah, that's the reason for it. I hope that answered your question. Okay, I think it's a two-part question. Let's answer the privacy first. All the data, everything that you feed is processed locally, so at least encoded locally, so that there is no privacy problem here because it doesn't leave the house. And as far as personalization goes, the way we have it in Purple Home is you can say to the agent, like, I want bright lights. And if you keep saying that for some time, it's gonna remember it and try to do it again because it has a memory of what you taught. Or remember I told you it could use tools. One of the tool is the ability for the LLM to read text files. So we have a text file for an example. Let's say I want a movie scene, and I could say for movie, if I say movie scene, you should do this, this, and this. It's a text file that's stored locally. So when I say, hey, Agent AI, I want to watch a movie, it's going to first see, do I have something that's already written or in a text file using the tool? And it's going to read that. And it's going to personalize by knowing what I've previously said. And that's local to the house, so no one else would know it. So that's how personalization and privacy would go hand in hand. Okay. Thomas, could you explain what do you mean by home robotic agents? Do you mean like a robot dog, a robot arm, or something like that? I'm a bit confused as to what do you mean by okay vacuums? Well, of course, yes. As long as it can be controlled by a person using phones or anyway, it can be controlled by the agent. For example, remember I told you how it operates lights. If I say I'm gonna, I don't have a screenshot of that prompt, but if I say I'm gonna watch a horror movie and prepare the living room for the horror movie, it will control the lights, set it to a red color, and it will do all this in a step-by-step fashion. So remove the color bulb, use your vacuum cleaner, and let's say I'm out right now, I'm heading home, prepare the room, and if you say vacuum cleaner is also a part of your home, then it will automatically trigger it. Also, since it has memory, it also knows when was the last time you used your vacuum cleaner. So it will decide if it should use it now or if you just used it today morning. So yeah, that's totally possible. How do you ensure that you are not cooking? Fair, very fair question. So yeah, this is the problem any LLM model would run into, especially OpenAI, because there are still existing lawsuits that say LLM models are trained on the entire internet, even on restricted information. So, like you said, what is stopping these LLM models to just give me Windows activation keys or anything that I actually shouldn't have access to? And there is something called guardrails. When you say something or when you ask something, it doesn't actually reach the LLM model. There is a smaller or tinier LLM model before it reaches ChatGPT, and that will decide if your intent is something that is fair or if you're trying to do something malicious. And before even it reaches ChatGPT, it will revert back to you. That's the only way. ChatGPT by itself can't decide if you're asking a right question or if it can disclose this information. ChatGPT has no awareness for that. In fact, that's based on this is what the whole world of prompt engineering is built on. For example, you saw the set of rules, right? Apart from these rules, there are other prompts that are not shown on the screen, but it runs in the background. For example, when I'm saying when I'm saying ChatGPT or the agentic AI, do this, I also say accomplish this task as if your job depends on it. That makes zero sense. But that's a glitch, I can't say a glitch, but a bias because there is so much data that it's being trained on. So if I say this specific prompt, it's going to prioritize that. So that's kind of, so yeah, that's a gray line. It's guardrail wouldn't stop it but it's also not unsafe. It's still safe. I'm still getting the best out of the LLM model rather than exploiting it. But yeah, guardrails would be the answer to stop or try to control AI from doing unsafe behavior. Did you develop your own logic algorithm? Is this in context of agentic AI or the vision language model? If you're talking about agentic AI, it's basically an LLM, just like your ChatGPT. We are using GPT-4, so we are just using the response off of GPT-4 and kind of branching it out into agents and tools. But the brain that's answering all these questions is still GPT-4. So we don't have to build a new logic to do that. But if we go back to VLM, we have, since I said it has to run on edge, it can't run on cloud. We have not developed a model, but we have optimized the model to run on edge so that it can understand what you're saying. And we have a different model that can understand image. So yeah, it's not, I would say it's developing, it's optimizing and more fine tuning than developing. Okay. The questions?
Yep. Any more questions? So I think that's it from the students' side. So thank you so much, Ajay and Tivis, for this wonderful presentation. So even though I come from an electronics engineering background, so I found your talk absolutely engaging and insightful. So I hope that everyone here learned something new and inspiring. Also, a big thank you to all the students and participants for joining us, and hope to see you some more sessions in the future. Yeah, we'll be in touch.
Yes,
Thank
of
you
course.
so much.
And thanks everyone for attending the session. Thanks for the
Yeah.
question.
Yeah. Thank you so much, everyone. And thank you so much, Ajay and Tivish. Yeah. Thank you for your time. Yeah. Bye.
Thank you.